Hi pre-calculus. So in 1.3 we're talking about algebraic expressions, and so in the beginning we're looking at expanding. So the directions you'd see on a problem like this would say to expand, or maybe to simplify. Sometimes you'd see simplify. So if I'm going to take x squared, whoa, that's crazy that it gets brighter every time I put my hand under there. Anyway, x squared times x cubed is x to the fifth. X squared times 2x is 2x cubed. X squared times 1 is x squared. And then I'm going to FOIL the negative 3 through. So I get a negative 3x cubed. I get a negative 6x. And I get a negative 3. And then when I combine like terms, I get x to the fifth minus x cubed plus x squared minus 6x minus 3. And I'm done. Notice I can't put any of the x's together because we're adding and subtracting, and since they're not like terms, they don't have the same power, there's nothing else I can do here. For example number 2, I'm going to FOIL again. So 1 times 2 is 2. 1 times negative 3 root x is negative 3 root x. Root x times 2 is 2 roots of x. And then negative 3 root x times root x. I'm going to do it off to the side here. Root x times root x is root x squared. And the square root of a square goes away, so you just get minus 3x over here. Now, when I combine like terms, I can combine the two terms that both have root x in them. So I get 2. A minus 3 and a plus 2 gives me a minus root x when I combine those two together. And then I get a minus 3x. And I'm done. If you see on the next problem a cube outside parentheses, normally what you would want to do is cube everything in the parentheses. So I think a standard thing for you guys to think is x to the sixth minus 8. I think it would be really natural for you to want to cube both of those, but that's actually wrong. You can't just cube it because you have this minus sign in the middle. Whenever you have addition or subtraction, you have to go ahead and do this out the long way. So you're going to write x squared minus 2 times itself 3 times. And then you're going to FOIL the first two together, or distribute the first two. So x squared times x squared is x to the fourth. You get a minus 2x squared and a minus 2x squared for the middle terms when you FOIL, and then a plus 4 on the end. When I combine like terms, I get x to the fourth minus 4x squared plus 4 as my first parentheses now. It's these two multiplied together equals this. And then I'm going to bring down that third parenthesis that I've left off and haven't done anything with. When I do that, x squared times x to the fourth is x to the sixth. X to the fourth, I get a minus 2x to the fourth there. Negative 4x squared times x squared is negative 4x to the fourth. Negative 4x squared times negative 2 is, positive 8x squared. And then 4 times x squared is 4x squared. 4 times negative 2 is negative 8. And when I combine like terms, I'm going to come on over here since I'm kind of running out of room. I get x to the sixth for that first term. I get a negative 6x to the fourth, a positive 12x squared, and a minus 8. Notice that the final answer here is a lot different than just cubing both of the terms inside. You do get the x to the sixth, and you do get the minus 8 like we did if we were going to try and do it sort of a shortcut way but get the wrong answer. But you get these middle terms because of FOILing everything out. On the next problem, or next series of problems, we're going to be factoring. So I'm just going to remind you of some factoring patterns. The first thing you should always look for is if you can take out a common factor. So is there something that goes into 3x squared and goes into 6x? Now, 3 goes into both 3 and 6, so I can factor that out. And x goes into x, and it also goes into x squared, so I can take an x out. When I do that, it's essentially like dividing this by 3x. And so 3x squared divided by 3x is just x. And negative 6x divided by 3x is negative 2. And this would be the factored form of the original problem. Okay. If I see 3 terms, a trinomial, then I know I'm going to have to factor it into 2 parentheses. And I'm looking for two things that multiply to 12 and add up to 7. And so if you think for a second, two things that multiply to 12, well, it's either going to be a 1 and a 6. Oh, sorry, that 1 and 6 doesn't work. That multiplies to 6. A 2 and a 6, or a 3 and a 4. And so 3 and 4 have to work because 3 plus 4 is 7. On the next one, oops, sorry, hit the Elmo there or the Samsung, trying to move the thing. I've got 3 terms again, and I don't have any common terms, so that I can't take out a common factor. So I'm going to have to factor this into 2 parentheses. I need 2 numbers that multiply to 5, and 2 numbers that multiply to 6x squared. And I'm going to play just a guess and check game here. So I start guessing and checking. I'm going to do 2x and 3x, because 2x times 3x gives me 6x squared. And then I need 2 things that multiply to 5, so I'm going to guess 1 and 5. Now, it's got to be a negative 5, so one of them has to be a positive and one has to be a minus. And now I'm just going to check my work. Let's see, that gives me 6x squared. 2x and negative 5 give me negative 10x. 1 times 3x gives me a plus 3x. And together, those give me a minus 7x. Now notice, I want a plus 7x. So this is actually pretty close. It's just a little bit off. And I could fix it, I think, if I had a plus 10 and a minus 3. And I think I can do that if I just switch out my positive and negative. So I'm just going to cross this one out. And I get 2x minus 1 times 3x plus 5. Now I'm getting a positive 10 and a minus 3, which really will add up to 7x in the middle. So just guess and check on those bad boys until you get them right. I know it might take a couple guesses and checks, but it shouldn't be too long. A couple more factoring patterns, and then we'll be done. This bad boy, if you see something squared minus something else squared, it's a difference of squares. So this is going to be 2x minus 5 times 2x plus 5. This is your good old difference of squares factoring pattern. It's one that's going to come up a ton in pre-calculus, so make sure that you recognize it as best as possible. It happens whenever, so 2x squared is where the 4x squared came from, and 5 squared is where the 25 came from, and so it's literally the difference of 2 things that have been perfectly squared, and it always follows the form a minus b times a plus b. Okay. The next pattern we have is a difference of cubes. On this one, the thing that got cubed, 27 is 3 cubed, and so it's 3x cubed would give us 27x cubed, and 1 cubed would give us 1. And so this guy is called a difference of cubes. Now the difference of cubes factoring pattern says that if you have a cubed minus b cubed, that's equal to a minus b times a squared plus ab plus b squared. Okay. And some of you guys might remember the acronym for this, SOAP. Same, opposite, always positive. Okay. So it's the same symbol as the beginning, the opposite symbol as the beginning, and this one's always positive. So using this factoring pattern, I'm going to say, let's see, my a is 3x. So I'm going to have 3x minus my b, which is 1. I'm going to square my a, so 9x squared. Notice I squared the 3 and squared the x. Plus a times b, so 3x times 1, which is just 3x. And then always positive, b squared, so 1 squared, which is 1. And this is the factored form of my difference of cubes. The next factoring pattern is a sum of cubes, because this is x squared to the 3rd power and 2 to the 3rd power. So I have 2 cubes, 2 perfect cubes being added together. A sum of cubes says that a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So again, we've got SOAP, same, opposite, always positive. So in this case, I'm going to have a is x squared plus b is 2. A squared is going to be x to the 4th, because x squared squared is x to the 4th, minus a times b, so sorry, I did that backwards, a times b, 2x squared, and then plus b squared, 2 squared would be 4. And so there's x to the 6 plus 8 all factored out. Sum and difference of cubes are the trickiest factoring patterns. You need to make sure that you have these memorized. And then let's see, for g, if you see 4 terms is factored by grouping. So you're going to group the first 2 and group the second 2, and then you're going to factor each one separately. So out of the first 2, I can take an x squared, and then I have x plus 1. Out of the second group, I can take a plus 4, and I have x plus 1. And now that I have x plus 1 in each one of these terms, I can factor the x plus 1 out, and I'm left with x squared plus 4 in the inside. And that's completely factored there. So factor by grouping, you group the first 2, group the second 2, take out common factors, and then you should always get the same thing in both sets of parentheses. You're going to factor that out in front and rewrite what you have left over. Finally, we have a problem that's mixed. Now, the first thing I can do on this one is take out a common term. They both have an x, so I can factor that x out. They both have a y squared, so I can take that out. And then what I'm left with, well, x to the 5th divided by x is x to the 4th. And I took the y squared out, so that's gone. And then I factored the x out. Y to the 6th divided by y squared is y to the 4th. Okay. You're not done yet, though, because you've got a difference of squares now, since x squared squared minus y squared squared. Do you see how x to the 4th could be written as x squared squared? So this really is a difference of 2 squares. So I can factor this as x squared minus y squared times x squared plus y squared. And then I have a difference of squares again, so I can factor this as x, y squared, x minus y times x plus y. This, however, is a sum of squares, which doesn't have a special factoring pattern, and so you have to leave it. You can't factor that any farther. And here's my final answer. The moral of this story is factor, factor, factor until you're completely factored. All right, I know these notes were a little bit longer, but I feel like 12 minutes, still not terrible for a bunch of factoring patterns. Go ahead and get these copied down, write down everything that you see, and then I will see you in class tomorrow. Have a good night.